Hi everyone, in my last videos I used industrial reducer like this one. This is planetary reducer. And today we're gonna build our own reducer using pulleys and belts, like for example this one. And the idea is to compare two reducers. So planetary reducer which I have, it has a quite high reduction ratio of 32. And for example this belt system has a reduction ratio of only 2. And the thing is that some people, they prefer high reduction ratio because it will allow you to have a very powerful robot. But other people, they say that low reduction ratio is better because with a low reduction ratio you have very agile robot with motors which is easily back drivable, and apparently this helps a lot. So today we're gonna compare this. Don't forget to subscribe to this channel over here, and let's do this. Here there is all the parts which we need for building a new reducer. So this is electronics with ODrive. This is a brushless motor. This is an arm from my previous video. This is aluminum profile on which I will mount the reducer. This is the pulleys for the reducer. These two pulleys has a reduction 2. This pulley is 2 times smaller than this one. And these two pulleys has a reduction of 5. This is 3D printed parts. This is 2 axes, bearings, and some small other stuff. So first axis goes here with the bearings, and on this axis I'm gonna mount this pulley and this pulley. Second axis goes here, and it's gonna hold this pulley, and this small pulleys goes to the motor. These two printed parts squish this pulley between them like this, and I have these holes to fix the arm, something like this. So let's assemble all of this. Aluminum profiles. So on this aluminum profile we will fix pulley like this, and this is the mount for the motor. So motor is gonna be put in between them, and there is holes. So motor, first pulley set, second pulley set. Now we're gonna assemble the pulley. Stage is assembly of the axis, and let's start with the big one. This one. So we would need spacers, and bearings. This one goes here, on top of it should go bearing. I installed this bearing, and now we can continue. The second bearing is installed. Nice! Now the second axis, so this one. I also found these two pulleys, which we can use for different gear ratio in our system. So I would like to change this pulley for this one to have the highest gear ratio. Nice. Now we will assemble everything on this rail. So let's put this aside. Let's start with this one. Bigger belt. I installed the slightly bigger belt here. So this is the system so far. Cool. I just need to fix this pulley. It's done. Let's do this. Let's see how it works so far. Okay, calibration procedure. Nice. Fuck, it's strong. There is not much backlash. This is nice. This is what I was expecting. Cool. Now let's talk about this. We have pulleys type GT2, 20Ts and 100Ts. We have the pulleys type GT3, 20Ts, 60Ts and 120Ts. And with this pulley and two axes which we just built, we can give this gear ratio 1 to 2, 1 to 6, 1 to 10, 1 to 30. And just to remind you, in the last video, when I used this planetary industrial gearbox, this planetary industrial gearbox has gear ratio 32. And we use this with the speed 130,000 counts per second and with the current threshold 7. So we can recalculate this to different gear ratios, like it's shown here. So with a smaller gear ratio, we need a higher current threshold and a lower speed to have the same speed of the arm. But we can see that for the very low gear ratio, the current goes too high. It's higher than the limit of the ODrive controller. So I'm not gonna follow all these values, but I will use them as a guideline. So everything is assembled, the gear ratio is 30, the highest for today, and I already uploaded the program to the Arduino with the correct values of speed and current. So let's start. Calibration sequence. Are you coming back, guy? Really? Seriously? Okay. Please. Okay, there is something in the program. I have to check it. I have to correct it. See you in a second. New program is in Arduino, so let's start and see how it works. Not bad. Looks the same, feels the same as with industrial reducer. Cool. Let's now reduce the reduction ratio. I wanted to show you that now it's so much easier backdrivable. I mean, it moves so smoothly. And all this just because the reduction ratio is 10 instead of 30. Reduction ratio 10. And it should start from this position. Sorry. Yeah. Whew. Calibration. Nice. Nice sound actually. So for reduction ratio of 6, we don't need this axis. So it's gonna be just this pulley and motor. Now I need to change the program on the Arduino to increase the current and decrease the speed in order to match the original parameters. So guys, I tried to run this and I had a huge problem. The thing is that I did not change properly the speed. And this guy, he just pushed like this with all its speed it has. It broke this finger. It broke this piece. It scared shit out of me. And it was so noisy, it was so powerful. Everything just flew away. And I don't know, I cannot find this finger. I was looking for it like for maybe 10 minutes in my room, but I cannot find it anywhere. I don't know where it flies. This was shit. I think I'm gonna just dismount this arm. It's kind of dangerous. Maybe not with this power. Maybe I should not use so much current in this motor. At least before I'm 100% sure that it works properly. So I finally managed to find a missing finger. You see how it broke? And also the second, this second bracket was also broken. I did not saw it at the beginning. So one wrong calibration with this motor, and this is all the damage which I have. So I think this ODrive and this motor is super powerful. And I have another damage. I can show you, but this axis is actually now tilted. You see? So I think this is the end of this test. The motor is still working. This is nice. So the conclusion, we built a gearbox with the belts and pulleys. And first of all, this gearbox has zero or almost zero backlash, which is a very good. And this is a gear ratio which we wanted to test, but finally we tested only two of them. And so the first one, 1:30, is very close to the gear ratio of the industrial gearbox from the previous video. And what is good, that it feels the same, the high five motion, it looks the same, it tastes the same, so everything is the same except that we have zero backlash. With the lower gear ratio, it feels much better. So when you make high five, it feels like more agile and more like natural movement. And maybe because with this gear ratio, all the system is much easier back drivable. So, and with this gear ratio 1:6, we had some accident, and this was super scary actually. And this actually showed me that this motor and this ODrive controller has enormous power, because in just one snap like this, it broke two brackets, and also it broke a finger from my hand, you see? So, in brief, the conclusion is ODrive has a lot of power, and it feels like for the agile robot it's more advantages to use a lower reduction ratio with respect to high reduction ratio. That's it for today. Don't forget to subscribe and see you next time.